applied parallel to its length. So when we read the effect, when a ferromagnetic rod is subjected to an alternating magnetic field parallel to its length, as shown in the figure, the rod undergoes alternating contraction and expansion of a frequency equal to the frequency of the applied magnetic field. That means when a frequency of a magnetic field having some particular frequency is applied to this rod parallel to its length, this rod will start contracting and getting expand, as well as it will get contract, and it will vibrate with a particular frequency which is equal to the frequency of applied magnetic field. Now due to this effect, resonance will be created and this rod will vigorously vibrate and create a frequency of ultrasonic waves. As we are going on the slide, next slide, here you can see that this is the diagram or circuit diagram of a oscillatory circuit, or if I say resonant circuit. In the diagram you can see that a rod which is wounded with two coils, one is with coil L and another is with coil L1. In coil parallel to L, there is one variable capacitor which is parallel to the coil L. Here a transistor is also kept and it is given a DC source. It is joined with a DC source. So in construction, what you will see that L coil is in parallel connection with the variable capacitor, which is also called a tank circuit or a resonant circuit. The L and C parallel is fed to the collector of the transistor, and the one end of the coil L1 is fed to B and the another end of coil L1 is fed back to the negative of the battery or to the common. So this is the construction of this circuit. Now let us move to the next slide. Construction. The ends of ferromagnetic rod A and B is wounded by coil L1 and L. The coil L is connected to the collector of the transistor and the coil L1 is connected to the base of the transistor, as we show in the figure. The frequency of the oscillator circuit can be adjusted by the condenser C, that is the variable capacitor, or it can also be called condenser C, and the current can be noted by the milliammeter connected across the coil L. Moving towards the next slide, the battery connected between emitter and collector provides necessary biasing, that is emitter is forward biased and collector is reverse biased for the NPN transistor. Hence, the current can be produced by applying necessary biasing to the transistor with the help of the battery. Now, what will happen? Let us go to working. But before that, why transistor is kept in this circuit? Transistor is having the application of working as a switch, or it can be worked as a oscillator. So one of the application of transistor is an oscillator. So this transistor or NPN transistor is placed in this magnetostriction circuit. Let us move towards the working. The rod is permanently magnetized in the beginning by passing direct current. I repeat, the rod is permanently magnetized in the beginning by passing direct current. The battery is switched on and hence current is produced by the transistor. The current is passed through the coil L, which causes a corresponding change in the magnetization of the rod. The current is passed through the coil, which causes a corresponding change in the magnetization of the rod. Now the rod starts vibrating due to the magnetostriction effect. When a coil is wounded over a vibrating rod, the EMF will be induced in the coil, called a converse magnetostriction effect. Due to this effect, an EMF is induced in the coil L1, and the induced EMF is fed back to the base of the transistor, which act as a feedback continuously. In this way, the current in the transistor is built up and the vibration of the rod is maintained. Now, the frequency of the oscillatory circuit is adjusted by the condenser C, and when this frequency is equal to the frequency of vibrating rod, the resonance is created, that is, the two frequencies, one frequency of the oscillatory circuit and another frequency of the vibrating rod, when matches, the resonance is created, and at resonance the rod vibrates longitudinally with larger amplitude, producing ultrasonic waves of high frequency along the both ends of the rods. So on the next slide, here you can see the condition for resonance. Frequency of the oscillatory circuit is equal to the frequency of the ferromagnetic rod. The equation can be represented here. Here you can see that this is the frequency of oscillatory circuit, that is F is equal to 1 upon 2 pi under root L C, and frequency of the vibrating rod is 1 upon 2L into under root E upon rho. When this both equation matches, that means when with this both equation is equal to each other, resonance is created and ultrasonic waves is generated at the end of the ferromagnetic rod. Here C1 is the condenser, and by changing the value of C, you can change the value of F. By changing the value of C, we will change the value of C, which will keep a particular value of F, which is equal to the frequency of vibrating rod. Here L is the inductance, C is the capacitance. By changing the value of capacitance, you can change the frequency of oscillatory circuit. And to create a resonance, we should control the value of frequency of oscillatory circuit, which should be equal to the frequency of the vibrating rod. And when this both equation will be equal to each other, the rod will vibrate longitudinally with high amplitude and will create or generate or produce ultrasonic waves. Here L is the inductance, C is the capacitance, L is the length of ferromagnetic rod, rho is the density of material, and E is the elastic constant or Young modulus. So this was the question which is asked for nearly about 7 marks. This is the question of 7 marks which could be asked from ultrasonics, that is the production of ultrasonic waves using magnetostriction method. There are nearly 2 methods which is being explained in the engineering physics, that is piezoelectric method and magnetostriction method. So in June-July 2011, magnetostriction method was asked for 7 marks. It could be also asked for 5 marks or 4 marks also. Let us move towards the next question. And before moving towards the next question, we should see the merits and limitations of magnetostriction method. First, magnetostrictive materials are easily available and it is inexpensive. That means the cost is very low. Oscillatory circuit is simple to construct. large output power can be generated with the help of magnetostriction method. So these are the merits of the oscillatory circuits. Let us move towards the next point. These are the limitations. It can produce frequency up to 3 MHz only. That means this is the first limitation of magnetostriction method. Second, it is not possible to get a constant single frequency because rod depends on temperature and the degree of magnetization. That means the ferromagnetic rod is temperature dependent and the vibration and frequency of the rod is dependent on temperature. While going on the third point, the frequency is inversely proportional to the length of the vibrating rod. To increase the frequency, the length of the rod should be decreased, which is practically impossible. So by decreasing the rod, you can increase the frequency, but practically it is not possible. So this is one of the limitation of magnetostriction method. On moving towards the next question, question 3a. This question is asked for 6 marks. Here you are asked to define lattice and basis. Derive the expression for interplanar distance d for a cubic lattice. Before writing the answer, you should define lattice and basis, and after that you should derive the expression for the interplanar distance d for cubic lattice. Lattice is an array of points such that every lattice points has got the same environment, or every lattice point is indistinguishable from the other lattice points. That is, it is a totally imaginary concept. That means lattice are some of the points or the group of points which having the same environment to each other and which are indistinguishable from each other. Moving to the basis. Bases are the molecules or atoms, that is the assembly of molecules or atoms. A crystal structure is formed by associating with every lattice points a unit assembly of atoms or molecules. That is, one or more atoms or molecules are identical in composition, arrangement and orientation. This unit assembly is called basis. That means atoms or molecules are taking place of the imaginary lattice points which are being thought by us in space. That means in space we are thinking some points which are at particular distance from each other and having the same environment, and on that particular lattice points bases are fixed. That means atoms and molecules are fixed, and when lattice and basis are added, that means lattice plus basis will give a particular crystal structure. So this was one of the definitions of lattice as well as basis. Before going to the explanation or derivation of the interplanar distances, I am going to show you some diagrams related to interplanar distances. Let us move towards the next slide. Here in this equation, H, K and L represents the family of planes. That means H, K and L are the Miller indices of a plane. All parallel crystal planes have the same Miller indices, and these planes are equally spaced at a distance d, h, k, l, and this distance is defined as d is equal to a upon under root h square plus k square plus l square. Now I want to show you a diagram in which you can see that actually what is the distance between the two planes, or where there is a distance between two planes. Let me show you on this paper. Here we are thinking of a coordinates. This is x coordinate, this is y coordinate, and this is z coordinate. And the triangle here A, B and C, you are seeing with respect to this O. First of all, just observe this O line which is passing perpendicularly through this plane ABC. And this ABC is having some intercept OA, OB and OC according to this origin. So if I consider the origin, then from this origin to point N, the ON represents the interplanar distance. That is, ON can be represented as distance. I repeat, ON is equal to the distance, and this is the interplanar distance. So if I draw one another plane above this line, then there will be distance between two planes which is same as ON. That is, one plane, on that above parallel another plane, on that above parallel another plane. This diagram is represented that this O, from this O, the perpendicular line which is drawn and which is passing through this plane is making the angle with this coordinate x, y and z. Here you can see that alpha is the angle made by this perpendicular line with x axis, beta dash is the angle formed by this perpendicular line with respect to y axis, and gamma dash is the angle formed by this perpendicular line to z axis. So this is the plane which is being imagined in this axis. So this was the diagram related to planes. So these are the questions we are discussing today up to the interplanar distances. We conclude up to this.